Good morning, 5P. This is Mr. Wong. Today is the 27th of April, Monday. Okay, so for today, we will start on the next SIN, which is using electricity, where we will learn more about bulbs and batteries connected in both series and parallel arrangement. And then after that, we will also continue on with our topical worksheet on electrical systems. Try to finish it before the end of HBR, right? Okay, so this was your homework last Friday on electrical systems on series and parallel circuit. Most of you got the idea, but you all kind of put in the wrong word for the wrong bracket. Okay, so your homework was 2 pages of SIN on last Friday, as well as I think 8 questions on MCQ. So let's go through them first. Okay, so what is a series and a parallel circuit? This is from the video from the lesson last Friday. You will learn what's a series and parallel circuit. So the first one is a series circuit. So let's write the first one down first. Okay, a series circuit. Okay, let's make it bigger so you can see. Okay, a series circuit is a circuit with only one path for electric current to flow through. Okay, only one. And what do you mean by only one? Okay, if I trace the path where electric current flows, there's only one path. Okay, there's no like another path. Okay, there's only one path. Okay, so this is what we mean by only one path. Okay, this is what we mean by only one path. So a series circuit only has one path. So what happens that when one of the bulbs is blown or when one of the bulbs is removed, what happens is that when, let's say, one of them is out, the rest of the bulbs cannot work because there will be a gap in the circuit. It will be an open circuit. Okay, so that's the problem with series circuit. Of course, it has its own benefit as well, but this is one of the disadvantage. So in a series circuit, okay, referring to one on top as well, when one bulb is removed or blown, for example in this case, the rest of the bulb will not light up. Okay, because there will be an open circuit. Okay, so the reason why the rest of the bulbs will not light up when one bulb is blown or taken away is because it will leave an open circuit, and we know open circuit electric current cannot flow through. All right, okay, so the reason why for series circuit, when one bulb is blown or removed, the rest of them will not light up, because once a light bulb is blown or removed, there will be a gap here and it becomes an open circuit, so the rest of the bulbs won't light up. Okay, so on the other hand, other than series, we have something called parallel. Okay, a parallel circuit has more than one path for the electric current to flow through. So let's look at the path. So let's use a different color. Let's use green. Okay, so for this case, you realize the electric current can flow through here, this one path. Okay, the electric current can also flow through here. Okay, electric current can also flow through here, which is the second path. The electric current can also flow through here, which is the third path. So you realize it can go by different paths. This is like different ways to get to the same destination. You realize there's I can use 3 different colors to represent the 3 different ways the electric current can flow. So this is to show you that parallel circuit can have more than one path for the electric current to flow. And therefore, in a parallel circuit, when one bulb is blown or removed, let's say I take away this bulb in the center, the electric current still can flow through the first bulb, still can flow through the third bulb, and that's why the rest of the bulb still remains lighted up. Okay, so that's the advantage of having it in parallel. So in parallel circuit, when one of the bulbs is removed or blown, the rest of the bulb will still light up, because the electric current can still flow in other paths. Okay, so for example, the center light bulb is blown or taken away, the electric current can still flow through the first light bulb, can still go by another path to go through the third light bulb. Okay, it has its own path. Okay, so that is the good thing about parallel circuit. Okay, so over here, let's also write this down. There are three paths. Okay, all right, let's go to the next page. All right, so what happens? Okay, so series and parallel circuits are quite widely used in the world outside, okay, in our real life. So let's say I have a Christmas tree. Let's go back to blue color. Let's say if I have a Christmas tree, I want to decorate a Christmas tree. There's a long wire of light bulbs connected to it, and I go round and round the Christmas tree. But I realize all the bulbs never light up. So in terms of arrangement, some of you never explain in terms of arrangement. Okay, in terms of arrangement, why the bulbs never light up? Okay, is because most likely, okay, it's quite a long one. So bear with me. All right, go in terms of arrangement, it might be the bulbs are arranged in a certain way. So the bulbs might or may be arranged. It may be connected. Sorry, maybe you can use arrange. You can use connected as well. May be connected in series. Okay. Alright, you realize you have a long chain of wire with a lot of light bulbs connected. They may be connected in series. So when they are connected in series, if there's a gap, okay, if there's a gap in the circuit, or if one of the bulbs is blown, the rest of the bulb, there will be a gap in the circuit. You There will be a gap in the circuit. Yeah. Okay, to write it better, because I mentioned the gap in the circuit already, so it leaves an open circuit where electric current cannot flow through. Right. Okay, so let's look at the answer again. So okay, maybe this will be easier for you to copy. Okay, the bulbs may be connected in series because there's a long coil of wire with a lot of bulbs connected to it. So the bulbs may be connected in series, and when the bulb is connected in series, if there's a gap in the circuit, for example, let's say the wire is broken, is spoiled, disconnected, or if one of the bulbs is blown, it leaves an open circuit. And what we know about open circuit is that when it's an open circuit, the electric current cannot flow through, so the bulbs do not light up. Okay, so that's the problem with series circuit. Once there's a problem in between somewhere, maybe the bulbs blown, maybe the wires, something wrong with the wire, you it's very hard to trace where is it, and then everything doesn't work, and then you can't use it anymore. Okay, so on the other hand, I have this boy that lives on the third level of a flat. One day the lift was out of order, so he had to climb the stairs. So as he climbed the stairs, he realized that the lights, okay, the corridor lights on the first and third floor were working, but the second level were not. So you would expect the whole block be go as in the whole block will be affected, the whole block, all the lights will be out. But in this case, you realize that the first and third floor lights were working, but the second floor lights are not working. So once again, in terms of arrangement of lights, explain why this can happen. So same thing. Okay, in this case, it will not be connected in series, it probably connected in parallel. So let's write that down. Okay, so the lights may have been connected in parallel, could be been connected. Okay, so when they are connected in parallel, when the electric current cannot pass through a certain path, it can still pass through other paths that is available. So although the electric current is unable to pass through the path for level 2 for the lights on level 2, it is still able to flow through the paths for the level 1 and the level 3 lights. Okay, right? So what I'm saying here is that you realize that level 1 and level 3 lights are still working, but level 2 lights are not working. So perhaps they have been connected in parallel. What we mean by that, when we are connected in parallel, although the electric current cannot pass through the path for the lights for level 2, that's why level 2 is lights out, it is still able to pass through the paths for level 1 and level 3. It's like an alternate path. Okay, the level 1 and level 3, the electric current can still flow through, but for level 2, because there's something wrong in the connection for level 2, lights cannot pass through, the electric current cannot pass through, the lights did not get switched on. But for level 1 and level 3, it is still business as usual. The electric current still can pass through as per normal, right? So there's a bit of digesting to do, there's a bit of copying to do. So you can pause the video and look at it at a deeper level and understand what does it mean by being connected in series when being connected in parallel. Okay, so now let's move on to the topical worksheet for electrical systems. Okay, this is page 2. We're going through question 3 to question 10. I'll be looking at the time. If I take too long to go through, I may just stop and then continue on going through another day. All right. Okay, so let's look at question 3 first. Tina wanted to find out how the wires behind a circuit card shown were connected. So I got point A, point B, point C, point D, point E, and a circuit tester. Remember, a circuit tester to test whether that, for example, the 2 points connected, is it a closed circuit or open circuit. If it's a closed circuit, the light bulb will light up. If an open circuit, the light bulb will light up. So let's write what we know down. So if it's a closed circuit, okay, it will light up. And then if it's an open circuit, it will not light up. The bulb will not light up. Okay, so with that understanding given, you will realize the result is as such. When I connect to A and B, light bulb did not light up. So which also means, let's highlight this part, this is quite important. When A and B is connected to the circuit breaker, you realize that the light bulb did not light up. So what does this mean? This means that A and B is not connected. They can be either directly connected or indirectly connected, but I know they are not connected. So let's write down here first, and then let's draw an arrow to this. Okay, so I know A and B is definitely not connected. Let's find another one. Okay, realize that for B and D also the same. B and D, when you connect B and D to the circuit tester, B and D do not allow the light bulb to light up. So same thing, another one. So B and D is also not connected directly or indirectly. They might be connected indirectly, but for this case, if because the light bulb didn't light up, means it's an open circuit, means whether directly or indirectly, A and B is not connected together, B and D is not connected together, while A and E is connected together, and C and E is connected together. So let's highlight these two in another color. So I know A and E, when you connect them to a circuit tester, it lights up. C and E connect to a circuit tester, it lights up. So for this part, these are maybe directly or indirectly connected. Indirectly means maybe through another point they are connected. Okay, so this is for AE and CE. Okay, so understanding this, let's look at the options that we have. Okay, I know A and B is not connected, so A and B must not be connected. So A and B not connected, A and B not connected, A and B not connected. But you realize for number 3, A and B is indirectly connected, which also means that this is wrong. Okay, so when we say connected, it might be directly or indirectly connected. In this case, A and B are indirectly connected. So if I connect them to A and B, the electric current can actually pass through from A to C to E to D, indirectly connecting them. So it's a closed circuit. So by right, it should light up. So in this case, it doesn't light up. So it's not. Okay, it's not this circuit card. Okay, let's look at the other one. B and D not connected. Okay, let's look at B and D not connected. Correct. Correct, not connected, not connected. So all 3 are fine. Now let's look at those that are connected. A and E are connected. Okay, A and E, they are not connected. There's a gap over here. So this is wrong. A and E should be connected. A and E, that's not connected. You realize? And in this case, you realize A and E is indirectly connected. So it's correct. And then C and E is connected. C and E is connected. So answer is 4. Okay, so this one you have to really go through each and every one of them to see how they are connected. You can always trace using your finger or using a highlighter, trace the path of the electric current. Okay, so for this case, A and B is connected. A and B is not connected. Yeah, A and E is connected. B and D are not connected, and C and E are connected. That's why it fulfills this result over here. Answer is 4. Okay, let's look at this. I have an electric circuit here. These are batteries. This is a switch that is closed. There's 3 light bulb and there's X over here. Okay, so when she closed the switch, none of the bulbs light up. The problem is none of the bulbs light up. Which one is a possible reason why the bulbs don't light up? Batteries not working. Yep, batteries might have not enough power left already, so batteries might not be working. X is an insulator, correct? Because X is an insulator means it does not allow electric current to pass through. Okay, so if X is a electric insulator, means it does not allow electric current to pass through. Means that the bulb will not light up because there's no electric current passing through the light bulb as well. Okay, so this is this, and one of the light bulbs fuse, correct? If one of the light bulb fuse, means it will be a open circuit that's left behind, leaving an open circuit. So each of the points given, there is some thinking involved. Write them down so that you know so you know the bigger picture of the question. You don't just read, and read. Okay, there are things that you can write down. Okay, so this one, telling me that the bulb has fuse probably also tells me that it leaves an open circuit, which that's why the light bulb doesn't light up at all. So all 3 are possible reasons. So A, B, C, answer is 4. Okay. Okay, let's try the next one. Okay, in the circuit below, one of the objects A, B, C, or D, okay, only one of them, A, B, C, or D, is an electrical insulator. Once again, write down what you know about insulator. That means does not allow electric current to pass through. Okay, so every time you have keyword like electrical conductor, electrical insulator, write down what you know about them. Okay. Okay, so one of the objects A, B, C, D, one of them only is an electrical insulator, do not allow electric current to pass through. When I close the switch, only 3 bells ring. Only 3 bells ring. 1 bell did not ring. Which one could be the insulator? So let's go and test it out. Let's say A. Let's say if A was the insulator. Insulator means does not allow electricity to pass through. Okay, so if A was the insulator, let's trace the path of electricity out. if A was the insulator, means the electric current will flow through, and then get stuck. It can't pass through, and you realize it can't even go back to form a complete loop. It cannot even form a open circuit. So if A was the insulator, none of the bells will ring. Okay, these are bells. None of the bells will ring. So I want 3 to ring, so it cannot be A. Okay, so now let's erase this. Okay, so now let's try. So what if it's B? If B is the one that doesn't allow electric current to pass through, so let's trace the electricity again. Electric current will flow through the bell, go through A because it's a conductor, flow through the bell here, flow through D, and then flow through here, correct? You realize that electric current can't flow through to the right, and therefore cannot reach this bell and this bell. So if B was the electrical insulator, only 2 bells will ring. I want 3, so it's wrong. Okay, so this is wrong. Okay, let's erase this away. So we try C. If C is the electrical insulator, so let's trace the electric current again. So yep, this one is still a complete path. But let's say if I flow over here, it looks okay, but you realize I get stuck. It's not a complete path. So if it's not a complete path, everything from here onwards will not work, but this complete loop will still work. So if C was the electrical insulator, only this bell and this bell works because it forms a complete loop, complete circuit, closed circuit, while the rest there's a gap. So this part cannot work. So again, C cannot be because if C was the insulator, only 2 bells will work. So let's try D. Okay, so let's try D. Okay, so if D is an insulator, we trace the electric current. Okay, over here, you realize if it goes here, it gets stuck, so this bell cannot work. But you realize that I can go to the right, this bell works, and it becomes a complete circuit. So if D was an electrical insulator, only this bell cannot work because it doesn't form a complete circuit, it doesn't form a closed circuit. This bell can work, this bell can work, this bell can work. So 3 bells, so answer is D, answer is 4. Okay, maybe we just go through one more question. Oh, a bit difficult. Okay, never mind. We'll go through question 6 onwards tomorrow. You see how much we can go through. Okay, so I'll stop here today. We'll go through question 6 onwards tomorrow. Today we will learn about the effects of the number of batteries connected in series on the brightness of the bulbs in a circuit. Okay, this one will be on another lesson in SIS today. Okay, see you tomorrow.